Hey folks, look at I got dressed. It's really a big victory for me today. Um, so look, we need to do U substitution, and this time we're going all the way through it, okay? I do want to make sure of one thing before we do anything with U substitution. I just want to make sure we're all in agreement on this. I'm just going to do an easy integral. Let's say I got 3x squared dx, and if I integrate that, do you agree if I integrate this, notation wise, that integral sign goes away and that dx goes away, right? That's how we've been doing it ever since we learned integration. So I would just do x cubed, and then this is an indefinite integral, right, with no limits. So I'll just do the plus c and I'm good, right? So you notice that, right? You're going to remember that, right? The integral sign goes away and the dx goes away, okay? All right, so let's do a U substitution from start to end. That way you can see why the random scale that you learned yesterday, how it comes into play. So 3x squared times the sine of x cubed dx. So we learned yesterday that I'm sure that was nothing important. That we learned yesterday that the U, I'm having a really hard time thinking. Oh my gosh, the U is the part of your function that has its derivative elsewhere in the function. Okay, so I'm looking right at this x cubed and I'm saying, oh my gosh, does it have its derivative elsewhere? Yeah, good. So that's my U. All right, so here's the part we did already. U equals x cubed. Let's solve for du. Du equals 3x squared dx. That's what you learned yesterday, right? Now, here's why you learned it. Because when you rename the function using these u's, you kind of uncover a hidden structure in that integrand. Sometimes people can see it already. Like they never even need to do the u's. For an easy one like this, I could probably do it on my own. But honestly, for some of the more complicated ones, I need to do U substitution. And you definitely should, because it's a great technique and it'll be on the AP test. All right. So look, everything in this top line here, I am now going to rewrite, but I'm going to use the U stuff that we just went through, all right? So check it out. Do I have an integral sign? Great, then I have an integral sign. And then I'm just gonna do this part first, okay? You agree I have a sine x cubed up there? Good, then I'm gonna do sine x cubed down here, but I'm gonna put it in terms of U. So I'm gonna write sine of U. And that's the same thing, right? Do you see that? Because we said U is x cubed. So these two are mathematically identical. And then check it out. What's left up in that integral that I haven't represented down here yet? Well, I'll tell you. It's this thing here and this thing here. Those are the two things that are not down here yet. But guess what? They equal. Look at this, people. Do you agree that du actually equals this 3x squared dx? So if I want to represent everything up here, down here, guess the only other thing I need to do? Shazam. Now you tell me, which integral is easier to do by hand? The bottom line or the top line? The bottom line, totally, right? So, well, I'll do it for you, but you probably have already figured it out. When you do the antiderivative of this, you'll get negative cosine u plus c. And then the last step is to turn it back into x's, which is not hard because you see this u here? Guess what u equals? We already set up there, u equals x cubed. So my final answer is cosine x cubed plus c. And you just did U substitution, okay? Look, we should double check it by taking the derivative of this and making sure we end up back here, okay? Up in our integrand. So if you take the derivative of this, can you see it's a chain rule thing? So I got a negative cosine of a blob. So what's the derivative of negative cosine? It would just be positive sine, I think. So we did the sine of that blob, and then times the derivative of the inside, and guess what? The derivative of the inside is 3x squared. All right? So this u stuff is good because it turns what looks like a difficult integral into an easy one by uncovering the chain rule structure that you might otherwise miss up there. Let's do another one. Okay. Let's say that I have 7x to the 6th and then e to the x to the 7th. Looks like a totally gross integral. Nobody could do that integral. Gross. But we have a technique now that can turn unsolvable integrals actually into something that we might be able to do. So let me ask you, do you see a part of this function that has its derivative elsewhere in the function? I do. Look at that x to the 7th, right? That is, it has its derivative elsewhere in the function. So that's my u. So I just write u equals x to the 7th, and then I solve for du. All right, now you try to do it. Stop this video and see if you can't rewrite this top integral, but this time using u's. Go. Okay, here's what I get. Integral sign, integral sign. I'm going to ignore this thing here for a second. I'm just going to focus on this guy. E to the x to the 7th. I'm just going to call that e to the u. And then the only other part that I'm missing up here is that stuff. But guess what? That's just what du equals, isn't it? So if I put a du here, then everything that's up here is now down here. And look at how easy that integral is. If you need to find the antiderivative of e to the u, don't think too hard. It's just e to the u, isn't it? And then just don't forget to turn it back into x's. So I'll have e to the x to the 7th plus c. Shazam. Okay? So look, that is the basic, that's the fundamental way to do u substitution. And I'll give you some practice at that. But while I got this video going, actually maybe I'll stop the video now so it's not obnoxiously long. Okay? Yeah, good.